Okay, so the two parametric equations, when they're graphed on problem number 43, they kind of look like this. And they want us to figure out when this is going to live in quadrant number 5. So just like problem number 42, but now we're in a different quadrant. So what we're really interested in is this section right here, okay? We want to know what values of t, are going to make this thing live right here, okay, in quadrant number 4. All right, that's what we're interested in. What values of t are going to exist right here? Well, what we know is that x is positive and y is negative, right? So we have a positive x value and a negative y value. So for the positive x value, what we're interested in is 3 minus the absolute value of t being greater than 0. Okay? And so what I need to do is I'm just going to subtract 3 from both sides. And I get negative 3 over here. Then I divide everything by negative 1. And I get the absolute value of t is less than positive 3. Well, that's kind of simple, right? And then if I were to solve this, I would say that t has to live between, well, that looks a little sloppy, 3 and negative 3. Those are the x values. Now, what that is talking about is the x values being greater than 0. And so, in reality, I'm also talking about these x values too. Right? And I'm talking about these x values. So now I'm going to try and do the same thing for y. Now for y, what I want to do is I want to take this, and I want to, y has to be negative, so t plus 1 must be less than 0. Or t has to be less than negative 1. Now if I were to graph this on a number line, we've got 0 here. And we can think of this number line as t. Now, if I talk about this right here, based on my x values, where my x values could be, it would be, whoops, hit the wrong thing there. So I'd have some business going on here. And then for t, I got to go from, t has to be less than negative 1. So now for my t coordinates, I got to go from negative 1 to here. Where did the two overlap? See, t has to be less than negative 1, so that would go that way. And I'm not quite sure if we're going to include those values or not, if they're going to be inclusive or not. In other words, am I going to have less than or equal to, or just less than? Okay? Because we try to avoid having points on the axis, because technically then it doesn't live in the quadrant, it lives on the axes. I want to talk about that in a second. But basically, where do these two overlap? Right here. So from negative 1 to negative 3 should be our answer. Because that satisfies both conditions. My x value is where it needs to be, and my y values are where they need to be. In other words, my x values are positive and my y values are negative. I need to satisfy both those conditions to live right right here. Okay? Now, one way that I could do that is I could come in and I can graph the equations on my graphing calculator. Now, my graphing calculator is already set up to parametric mode. I would encourage you guys to get yours out and follow along with me. So I'm going to get 3 minus the absolute value of t, and then t plus 1. Now, if I go into window and it says that the original parameters were from -6 to 6, I should get a graph like they have on the test, right? And that's what it is. And I'm interested in quadrant 4, which is this little deal right here. Now, what I've said is that if I go from -3 to -1, it should graph just the portion in the quadrant 4. Did it? Yeah? Does that make sense? Okay, some people are shaking their heads, some are kind of. So let me explain it again. So we got the right answer. You might not understand how it all fits together. Okay? The question on the test was, look at this graph. This graph is parametric equations, 2 of them, right? One for x, one for y. Can you tell us what values for t graph only quadrant 4? So what Mr. Adams did is I went in here and I said, all right, quadrant 4 occurs when x is positive and y is negative. So those are 2 conditions that I have to meet. What values for t make x positive, and what values for t make x negative? Since it's already written in parametric equations, I said that my x value has to be positive, which means it has to be greater than 0. That's the fancy way of saying positive. I went through and solved that algebraically, and I said x values are positive from -3 to +3 for t. So if I let my t values be from -3 to 3, then if I let my t values go from -3 to 3, all of my x values will be positive. So I'm gonna, if I graph that though, that's referring to quadrant 1 and quadrant 4, because up here, my x values are positive, but so are my y values. So this represents all positive x values. But I only want quadrant number 4. So in order to find that, I need to know when y is going to be negative. So that means that t plus 1, which is how I calculate y, must be less than 0. That's the fancy formal math way to say negative is less than 0. I solve that algebraically and I say t is less than -1. So then what I did is I graphed here that t can be from -3 to 3, and that'll give me a positive x value. But the only way I can get a negative y value is when t is less than -1. So now I'm looking for the values for t that satisfy both conditions. Well, from -1 to -3, in other words, if I say -3 to -1, that should satisfy a positive x and a negative y value. To verify my results, I go into the graphing calculator. I plug in my parametric equations, and then I set the parameters for t. So, when I solved for positive x values, I said that positive x values exist when I let t go anywhere from -3 to +3. Notice that when I graph this, if you think of only the x values, all the x values on the graph are positive. But the question in the test was quadrant 4, which means that my y values have to be negative. So then if I come back in here and I look at the graph of where the two overlap, it has to go from -3 to -1. And that will give me a positive x value and a negative y value.